He just breaks it in a way that most people would say, no. Alrighty. Okay. So let's go ahead and start with the description of the new homework assignment, and then we'll go back and talk about socket programming, and we'll also talk about the new topic related to socket programming and file operations that we have not covered yet. In the previous class, when I ended, I kind of started to talk about select, okay, which is a mechanism where you can have a single threaded program to talk simultaneously to multiple clients and not having the faster clients to have to wait for the slower clients. Okay, so we'll do all that today. So we'll begin with just a quick look at the first homework. This will be the first homework assignment after the extension to root reader. Okay, so this program is called Socket 1 because it is the first one of the entire series. And this one will write a single program that can act as both a server and a client, not at the same time, but you will use a switch to determine whether it should act as a client or to act as a server. And the behavior of the program is very simplistic. It is not realistic, but it's used as a platform for us to learn about basic socket programming. And then the next one will be a little bit more realistic. Now, before we go even further, can anyone tell me what would be a good example of a program that combines a server and a client into one? Apache would not be a very good example because Apache is basically a web server type of program and not a client program. Yep.
The file transfer program.
It depends on the protocol that you're talking about.
Peer-to-peer.
Yeah, peer-to-peer, like a torrent. Every torrent client is also a server because it has to do the file sharing. So it's both a server and a client at the same time. Very good. That's a good example. On the other hand, FTP is not a good example. An FTP client is an FTP client. It usually would not act as an FTP server. An FTP server, on the other hand, is an FTP server. Normally, it would not act as an FTP client. Okay, so a peer-to-peer program is a very good example. And another example is something that I talked about last Wednesday. Remember I talked about Squid, the proxy server, the caching proxy server. That's also a good example because on one hand, it is a proxy server to serve clients, but on the other hand, it also has to act as a client to get content from the internet. Okay, so it is not unusual that you can have a program that can act as a server and a client, and sometimes at the same time, not just using a switch to control the mode of the program, but sometimes they have to do both at the same time. So in this program, the first thing you have to do is to understand how to deal with command line options, and that's one thing that we'll go over today as well. The options are not ordered unless otherwise specified, and in this case, only one part is ordered. If you see -- server as one of the options, that means you want the program to run in server mode. The lack of this option means the program will be running in client mode. So the default is client mode. If you see -- server, it is in server mode. The other option is -- socket, which always has to be followed by the actual path to a named socket. This is broken up into two consecutive argv elements. We'll kind of go over a little bit of this. Both the server and the client modes need to know the path to the socket. If these two options are missing, report an error and exit the program. So this option has to be there, and PATH in italic here has to be renamed with, it has to be replaced by an actual path to the socket. So it would be like, test sock dot something, or whatever, however you want to name the socket. Are we doing okay so far with the command line options? Yep.
So are we assuming that if you have a client, the only option it better be -- socket and path? That's the only option if you're
Correct.
starting up a client.
That is correct.
But the server could be, the -- server could come before or after the -- socket path combo.
That is correct.
Okay.
So, sure. So the first thing I'll do is I will just write a very simple program to illustrate how to access these particular components on the command line. So we'll go to today's folder. So if anyone wants to wants me to upload this, you can just send an email to me and remind me to upload it. So I'll just call this program command options, and I'll go ahead and include maybe a cdio.h because I'll use printf in this case. Int main. It is very important when you specify the main program or the main subroutine, you have to include the two options now. argc, which is the number of arguments, and also const char pointer argv. Oops, I missed one. There are two ways to specify this. This is actually a better way to do it because it means this is an array of pointers. Instead of looking at argv as a pointer of a pointer, it is sometimes better to look at it as an array of pointers. They are literally the same thing in C. Okay, if you use replace the single asterisk with double asterisk and remove the square brackets, it means exactly the same thing. But sometimes it's just better to look at it this way. So what I'll do in this program is I'm just going to write a very simple loop, which is while argc stay in this loop here. And in this loop, I'm not going to do anything that's fancy. All I will do is to use printf and say argc equals %d, which is an integer, and argv at that. Okay, I'll just do it this way. And then we'll specify argc here and specify argv here. And then after that, I will auto increment argv and auto decrement argc. All right. And also to make the compiler happy, I have to supply return 0. What is this program doing? As long as I have parameters that I have not handled, it will stay in the loop. For each iteration, it will print out the number of remaining arguments and also the one that I'm processing at this point, starting with the first one. In other words, argc is nothing more than the number of arguments that is remaining for me to process. Okay, and argv is the current argument that I'm processing. Okay, so I'll just write the program like this and compile the program. I don't think I will need the debug option, so I'll just specify. I will not specify that. Okay, I'll just run the program by itself, and it says there's only one thing that I'm specifying, which is the command line itself, the command itself to start this program. But I can also supply all sorts of stuff like dash server dash what is the other one, socket, let's say test sock, and so on, and you can see how it's printed out. Okay, you can see argc starts with 4 in this case because there are 4 items, 1, 2, 3, 4, and it will just print each one consecutively. The first one is really just the command itself. How did this program get started? The second one and up, they're basically whatever you specify. In other words, argv makes no distinction between the ones starting with double dash and the ones that do not start with double dash. So when you write your program, you have to deal with this, basically account for this. Do we have any questions?
How big is the array?
Sorry?
How big is the array?
How big is the array? The array is as big as it takes to store all of the options on the command line.
Okay, so it can go on forever?
It will go on as it will be as long as argc indicates. Argc is argument count, so it tells you that the number of items. In my program, I'm just using that as a counter of the number of remaining items to process, because then I don't need another counter to count up. I just need one counter. I would use the same parameter to count down, so I know how many more items I have to process.
Yep. So is it like a vector?
Which one?
Is it like a vector?
GV is like a vector. Yep.
So it just keeps adding space.
Keep.
It just keeps. It doesn't run out. And you can keep adding more items to the array.
It is guaranteed to have ARGC many items initialized. Because ARGC and ARGV, they go hand in hand. One tells you the number of items, and the other one actually stores the pointers to those command line options. Okay.
I thought that if you put const before a pointer declaration, that meant that the pointer could not change.
Yes, it depends on where the const is. In this case, it means whatever you point to cannot change. But if you put a const here, that means the argument itself cannot change.
Okay.
So there are multiple places you can put a const, and they mean slightly different things.
I'm sorry.
Go ahead.
Is there any point in putting a const there?
You mean here?
No, where you actually did.
Yes, because if I do not put a const here, okay, let the cursor come back here. If I don't put a const here, which is okay with the C compiler, I don't think the C compiler actually checks the type of the arguments for main at least. If I don't put a const here, then I can potentially call a subroutine that will change whatever ARGV points to. Okay. So in that case, that may not happen, because if this is all stored in a memory space that is protected, that I'm not supposed to change, that can generate a protection fault, a memory protection fault. So it is important to kind of respect the const part of a pointer, so that you remember when you're not supposed to change what the pointer points to, and when it is okay to change what the pointer points to. Yep.
So in this case, you have a double pointer, essentially.
Yes.
So the way you have it, is it saying that you cannot change the pointers that are being pointed to, or you cannot change the ASCII or the text?
You cannot but in this case it said you cannot change the character that is pointed to by a pointer that is pointed to by the argument itself.
Okay.
So the const part applies to the very last portion of the dereference.
Because the const is applying to the char.
Exactly.
Okay.
Yep. The const is only modifying the char in this case. You can move the const to here and also to here.
That's what I was wondering.
There are 3 potential places in here that can have the const.
Aren't two of those the same thing though?
No.
They're all different?
No, they're all different. If you look at the picture of how the dereference is working, okay, so we have ARGV, which is a 32-bit pointer in a 32-bit system. Doesn't matter how wide is a pointer. It points to a pointer that has no name. In this case, we can just call this ARGV bracket 0, which means exactly the same thing as a dereference. Okay, and that in return, points to the beginning of a string, which in this case is a character. Okay, so this is a single character, whatever it is. Okay, so I'll just say that this is a char, this is a character pointer, and this is a pointer to a character. Is that okay? So what we have here is const char, which means the const applies to the last portion here. I cannot alter this. Okay, but I can alter this, and I can surely alter this too. So that means you actually have 3 potential places to put the const, and they can all happen. They can all occur, independently. In other words, you can not have a const in the entire thing, or you can have 3 consts in this case to specify that you're not supposed to change this, nor that. Okay, is that okay?
Yep.
Okay. So in this class, this is not really the focus of this class. This is all basically C and C++ programming. But the understanding of the const word or the modifier is very, very important, because when you make subroutine calls, you have to respect the prototype of the subroutine. So whatever the prototype of the subroutine specifies which part is const, you have to respect that. And if you start with something that is const to you and you're planning to change it, you better have a really good reason to do it and know that it is actually okay to do so. Yep.
Tack, if you put the const after the char, would that make the char pointer const or the char pointer const?
You mean here?
Yeah, would that make your char pointer const?
That new const would apply to
Got
this
it.
part here.
Says-
So argv 0 itself cannot be modified, which is also completely okay
Right.
in our case because we are not going to change that either. In this program, the only thing that will make the compiler complain is to put a const on the last one. Then I cannot change argv, which means plus argv cannot happen because I'm not supposed to change it.
Okay, thanks.
All right. So I think this program, helps to illustrate, how your program can, read the parameters and process the parameters. I would suggest not to use global variables to indicate the mode of operation. I don't think there's any need to do it using global variables because from the main subroutine, you can determine the mode of operation and just call a different subroutine according to the mode. So by being in a particular subroutine, you already know which mode you're operating in, and therefore there's no need to use a global variable to do that. Just remember, global variables are evil. And the worst part of evil global variables is they're also very tempting. From time to time you would think, oh, maybe I'll just use a global variable to do that. And with enough global variables in a program, it'll just be impossible to debug it, because global variables can make programs extremely hard to debug. Mostly because when you look at the prototype of a subroutine, it doesn't say anything about the global variables that it can also modify or reads from. That's why they're so tricky. They're basically a backdoor way of doing things, and too many backdoors are definitely not good. Yep.
And they also pretty much completely eliminate the portability of your code. You can't say, hey, this function is really great. I want to use it in my next project.
Yep. Well, in this class, we'll also talk about multi-threading. Global variables also destroy the property of thread safe. Any subroutine that makes use of either static or global variables are very, very bad because they are not thread safe anymore. We'll talk about threading later on, but I just want to give you guys an idea of why global variables are not good. Okay, when it's operating in server mode, the program will first create the endpoint. We talked about that. In fact, I wrote the sample programs at the end of the previous class to deal with both the server end and also the client end. We will bind it to the socket path as indicated. If the path is not valid, or for some reason this will fail because you already have a file of the file name, for instance, report the error and explain why it failed. And for this part, I have supplemental notes at the end of the homework assignment description. I'll show you that later. Once successfully bound, set the endpoint to listen using the listen call. We talked about that also on the other day. Now you can set the depth of the queue to 3. In this case, we're saying that up to 3 clients can be waiting for a connection at the same time, and we are not going to reject anyone. If you set it to 2 and you have 3 clients potentially waiting, the third one will get a rejection. The third one will basically get a message, or it will fail to connect because the server says, nope, I'm not going to talk to you. But it is probably not necessary if you're going to start the client processes manually. Yep.
Last time when we made the example program in last class, it seemed like you were able to make as many connections to that program. As
yes,
you wanted to.
but that's only because I ran the server side without using a debugger, but I ran the clients manually. So if you think about it, the server is able to accept the connection, because once you accept a connection, then you're free to accept the next connection. So the server is doing things really fast, like it's back to the loop, it's back to the loop. But on the client side, I'm starting the clients manually. So I would type, on the command line, startup on client, and then the server would go like, okay, I'm done with the connection with this one. I'm ready for the next one,
So
and that's why
the connection at that
exactly. So
okay.
that's why in that case the queue setting or the depth of the queue setting, it did not really matter because I was starting the clients so slowly that the server was able to outrun the speed that I can type the commands.
Got it.
If I had run the server in GDB and put a breakpoint right after accept, then I would be able to show you what the client will see when it's trying to connect, when there are too many people waiting for connections already.
Okay.
Yep. So in this case, we will use an array of 3 file descriptors, and the use of an array is handy because you can use indexing to go through the items instead of saying FD1, FD2, and FD3, which means you kind of have to write special code to deal with each one. I would just use an array. The server should accept 3 connections from clients in a loop. Upon the acceptance of a connection request, send a string connection number blah 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 to the connection FD using dprintf. Dprintf is just like printf. The D stands for descriptor. In other words, instead of using printf, which means you don't need to specify which file you're printing to, because it is always printing to standard out, dprintf allows you to specify the file descriptor where of your target communication endpoint. So in this case, you would use the file descriptor returned by accept, which you will also store in the FD array for your dprintf. Once all 3 connections are accepted, the program will send a string, the circle is now complete, to all 3 connections. Then the program should close all 3 connections using the close function. So do not send the circle is now complete before all 3 connections are completed. Okay, because it's very easy to do it. If you just put it, right next to connection number X, and just in fact, if I did not specify once all 3 connections are accepted, then the easy solution is to copy and paste the string at the end of here. Yep.
Do you want it to print a literal \n, or do you want to move on?
Yes, that's just line feed. Thank you. I thought it would not be a bad exercise to see whether people can escape the \ itself. It's easy.
Yeah.
Once you send, the circle is now complete, then you will close all 3 connections using the close function on the file descriptors of each connection. After closing all 3 connections, the server program should close the file descriptor associated with the endpoint and then exit normally. Okay. Are there any questions about the server's own behavior? Stay in a loop, wait for all 3 connections. As soon as you get one connection, you'll send a confirmation message to the client and say connection number blah, \n or the line feed character. Once all 3 connections are done, then you will send another message, broadcast another message to all 3 connections and say the circle is now complete, and that's the end of the server's behavior. Make sure you close all the connections correctly at the end. If you're operating in client mode, it's even easier. In client mode, the program should create the endpoint file descriptor first in blocking mode and attempt to connect to the server using the socket path. So the socket path has to be passed to both the client and the server because they both have to know where, the server needs to know where to define the endpoint, the bind point of the endpoint, and then the clients need to know where to find it. So you need to supply -- socket with the same path to all programs that you are testing in this case. Once connected, a client only needs to read and echo the stream of connection file descriptor using the read function. So what that means is you just take whatever you read from the socket and then you echo everything to standard out. You take whatever is coming down from the socket and then you just print it out to standard out. I would just use the read and the write functions. The easiest way to do this is to read 1 byte and write 1 byte at a time. Do we know how to do that? Okay, so the very first or second program that we wrote would accomplish this. A client closes the connection file descriptor and exits when a read operation encounters end of file. Do we know how to detect end of file with the read operation? You already know that. So basically, when the server closes a connection, the client side will see end of file. That's how it knows the connection is terminated and it's time to get out and close the file descriptor. Okay, this part we haven't talked about the other day, how to set up a named socket. Okay, there's no equivalent to make MK50 to create a named socket. It is created automatically. The bind subroutine call will automatically create it. Now, if you break out of the program for any reason, if you type Control-C to get out of the server program, it would not have a chance to close the endpoint, and that means you will have to use RM to remove the named socket because your program doesn't automatically remove that. If you want to, you can kind of go through the trouble to detect whether a file of that name already exists and then unlink it, before you run the bind call. But I think it's just, okay to use to do it externally. It is not a part of your program. It's not part of the requirement that you have to detect that you already have a file of that name and then remove it, from inside your own program. How to test your program? Now, this is a little bit more complicated than your other programs. You will have to run in multiple terminals so that you can run, one socket run in server mode and then run the other 3 in client mode. Okay. Are there any questions about this one? Can you imagine the fun that I have when I write a test script to test this program? I have ones already written, but I think I might have deleted those, so I will have to start from scratch again. But this time I can do it instead of in Perl, I can try to do it in Python. I get to learn something new. Okay, supplemental notes, very, very useful. You can use a subroutine call called p-error to print an error message according to ernum. In other words, you don't even need to use ernum in your own program. All you have to do is to call p-error in this case. Now, p-error takes one parameter, which is a string. That string is not the message that you're printing. It is a prefix to the message that you're printing. The message itself depends on ernum. What you're supplying is just a prefix. In other words, you can say, this program is failing in this file on this line, and then the rest is done by p-error. It's really handy. Okay. Yep.
Is it a requirement that we use the file and line macros?
No, it is not a requirement, but I think it is very handy, and it's a little neat trick that you can do. The macros are also very useful. Underscore, underscore, line, underscore, underscore, and underscore, underscore, file, underscore, underscore are 2 predefined macros that you can use, and these are basically supplied by the CPP, the C preprocessor. Gives you these predefined macros. One tells you what is the current line number. The other one tells you what is the current file. So when you're writing, when you're writing code to debug your program to detect, cases where it really should not happen, but when it does happen, I want to make sure that people understand this is happening and this is why we are getting out of the program. It is very useful to tell people, or at least the developer, where to find this problem. Okay, where is this error occurring? In which file or which line is complaining about this? Okay, so in this case, you have to use sprintf to help yourself, to do this. I'll illustrate how to do this. And the first thing you want to do is to just, man 3 p-error to read the man page. It is a part of standard stdio, and then the rest you really don't need. ernum.h you really don't need once you have a p-error. You also need sprintf. I think that's also in chapter 3. sprintf looks like this. You can see that this is almost identical to printf with the exception of the first parameter. In this case, the first parameter is the destination. It stores the formatted string in this case. In other words, the formatted string is not sent to standard out. In this case, it is stored in the destination string. Are we doing okay so far with this? You should probably use SN as printf, if you want to be safe, because this one you supply the actual size of the array so that you won't run into, potential issues of buffer overflow and stuff like that. Okay. Any questions at this point? Let's go ahead and write a simple program to test, and see how this works. So we'll go ahead and write p-error test.c. In this case, I'm not going to use any parameters. And all I want to do is to say here's an FD, and I'll try to open the file that does not exist. So I'll say open log. And of course I cannot remember how to use it, so we'll just go ahead and command to open. First copy the count includes. Whoop, there. That will remove a little bit more than what I want. Specify just one or too many. The replacement should have done with using the parentheses, so I can specify, just the other part where I want to keep, this part I want to remove. All right. So let's remember how to use open. So flags.
ORD only.
ORD only. Okay. It doesn't matter because it really does not exist. Okay. And then we'll say if FD is less than 0, do the following. So in here, I'm going to allocate a buffer for the string. So let's string buffer. Let's make it 256. SN printf string buffer size of string buffer. So this way, I don't run into buffer overflow issues. And we'll say error in source on line number, and the colon is really the end of the prefix. So I just want to use the colon to separate the prefix of the error message from the error message itself. And that's all that I need. Oh, we need to specify the file and also the line number. Okay. So what the snprintf call is going to do is to format the string using the macros file and the macro line so that it will read correctly. Then I'll use print error with string buffer as the prefix. And return 0 at the end. Wow, I didn't make a mistake. There you go. That's the output of the error. The output of the program. This is actually p error does not send it to standard out. It sends the error message to standard error. But most of the time, standard out and standard error are mapped to the console as well, so they will both get displayed on the screen. So in this case, this part here, everything up to the colon. Oh, okay, it automatically has one colon, so I was redundant. So I didn't have to specify my own colon because it already appends one colon. But you can see, the source part is the underscore underscore file underscore underscore, and then the line number part is underscore underscore line underscore underscore. This is not required from your program. In other words, you don't have to do it like this with your own program. I don't see why you would not want to do it this way, because now that I have done it, it's just copy and paste in your own program. But it makes your error message very easy to read. And also, if anyone wants to figure out what the problem is, and want to fix the problem, they know exactly where the p error call was done, and so they can track down that part of the program and say, why is it having a problem at this portion of the program?
So is that the line number? Is that going to be where we created that string, right?
Yeah, can we look
The line
at your
number.
source code?
Where we tried to open.
Yep, let's take a look at the source code again. And
14 should be the open column.
Hmm?
Or not.
The
Well, the only problem that I had was, I put in the extra colon and the extra space, so I should have done it like this without my own colon and the space because it is automatically appended already.
But isn't the error on line 10 where you try to open a non-existent file?
It reports the error that is on when you refer to __ line. So if you want this to be more precise, what you need to do is to set a variable on this line. Okay, so you can say int line, and then on this line you say line equals __ line, and then later on you do not refer to the line of the SNPrintf itself. You refer to line, which is where the problem actually happens. Then it will reflect the actual line where the problem happens.
Thank you.
Yep. Well, we'll give it a try. Still GCC, and we run the program. So this time it reflects the correct line number because I capture __ line on the same line as the open call. And the file is always okay because we only have one single file. But the file name is actually very important when you have a program that requires multiple source files.
Okay.
Because in the case you have multiple source files, it is possible that in multiple places you can still detect the same kind of problem. And if you don't print out where from which source file, it may not be as helpful because then you have to go through all your source files and find all the cases of P error in that case. Okay. But the most important part is actually the stuff after the colon because it doesn't display just a number. It is not saying it's not just saying the file descriptor is less than 0. It's telling you no such file or directory. So that is very handy. Now I can change the error message by making the file itself. So I can say touch blah to create a file, and I can generate that message by changing the read permission of the user owner. So I'll change to root ownership first, change to root privileges, and then change blah so that the user owner cannot actually read it. So we have used chmod u-r, meaning the user owner cannot read the file anymore, and apply that to blah. Exit, and then run the program again, and this time it says permission denied. It's really handy. Okay. Are there any questions about this? No questions? I just think it is good programming practice when you encounter errors where it is cannot be recovered, and the program cannot automatically handle that error. Before you exit the program, print out a message. Tell people what is failing and where it is failing as well. All right. Any questions about this? And for those of you who want to use this, that's okay. I'm not gonna say that you cannot copy this code, and it's really kind of simple. So what you want to do is really just change this part into maybe a subroutine, because it's just useful. You don't want to have to copy and paste this code everywhere. Just turn it into a subroutine, but you just have to capture the line number before you call the subroutine, because otherwise it will just report a line in the subroutine itself, which does not reflect exactly where the error happens. Any questions? No questions? All right. If there are no questions, we'll continue to talk about the homework assignment, and we are really at the end of the description of the homework assignment. Any questions about that? Would this due date be realistic? You have 1 week. And you still have my sample programs from the previous class and also sample programs from this class. For the most part, given those sample programs are already given, your task is for the most part understanding those particular sample programs that I have written already, and just put them together in a way to make this homework assignment work. Because all the components are already written. It's just a matter of putting them together so that they work the way that it is specified in the homework assignment. So I think 1 week, should be enough time to do that. Okay? All right. So with this out of the way, we'll go ahead and talk about the next concept, which you will need for the next homework assignment. And we talked about it a little bit the other day. It is called select. So we'll go ahead and talk about select here. And we'll also go ahead and open up a terminal, or use one that is already open here, and say man to select, because that's the man page of the select call. We'll read the notes first to understand the rationale of the select call. It's pretty much a repetition of what we talked about already last Wednesday. Okay, so if you go back to the program, okay, and read the behavior of the program, it talks to multiple clients, right? I mean, that's part of the objective of the program, is to talk to 3 clients at the same time. So what is the big deal? Why do we need select when we can talk to multiple clients already? What is one pitfall, or what is one of the disadvantages of the program that we are going to write for the current homework assignment? What is so bad about it?
We're working through each connection sequentially, so if one connection is slow, it's hanging everybody else up.
Exactly. That is exactly the issue. I'm just checking to make sure that I have enough space. Okay, it looks like we do, because I have not deleted the other files that I have been recording. Okay, so let me just give you an example, using the logic. Okay, let's say, the 3 of you, on the first row are the clients that I'm supposed to talk to, okay? And I'm the server program. The server program always needs to be started up first, because otherwise the clients, do not have an endpoint to talk to. Okay, so I have to start up first. Okay, I'm starting up here, and then the user or my test script will start up each individual test, client program individual. So let's say, you're the first one that is, that my script runs as a client. So you would try to connect to me and say, hey, I'm here, and I'll reply with connection blah, and you will echo it onto your own standard out, using your own terminal, and then you will just be waiting at that point. And then I'll be ready to talk to accept another connection from the next client, and then when I'm done talking to you, tell you that your connection 2, and you echo it back, on your side. I don't even care whether you are done with that side, as long as my message connection number 2 is sent, or connection 1, because it may start with 0, connection 1 is sent, I'll move on to the next one. I'm ready to accept your connection now, and then send you connection 2, and then I'm done with the first loop, right? Okay, that doesn't sound too bad. I mean, I can talk to all 3 at the same time. But what if you are kind of, slow?
How'd you know?
And when I send you the connection number, 0 string, you decide that I am not going to read right about now. I'm going to take a break here. Okay? So my write operation is going to be blocked. Okay? This is assuming that the buffer size of the socket is really small, so that it won't even fit that string. But it is possible. Okay? In a realistic setting, sometimes maybe I want to send 20 kilobytes, and the buffer is not big enough to handle the entire packet, and you're not ready to accept all 20 kilobytes yet. So then what happens to the second client, which the user has already started up already? You're gonna wait. Okay?
Don't you feel bad?
But the other 2 clients may be actually capable of running much faster, but they have to wait, because I'm only talking to you, and until you take the entire string connection number 0 back to the line feed, I'm not even going to go back to check whether someone else wants to connect to the server. That is the problem. Okay? You can kind of imagine, what if Apache is written this way?
Sometimes I think it is.
Okay, because if Apache is written this way, that means it can only talk to one client at a time. If one client is not ready to talk or ready to take the HTML document, Apache is going to sit there and stop and just wait. But we have a whole class waiting to ask questions. I don't know. I mean, I need to talk to this guy first. I need to finish our conversation before we move on. That's the problem of this particular program. So the select call is going to handle this situation using a very interesting way. What the select call is saying is I can monitor multiple file descriptors. Now, in this case, a file descriptor is nothing more than an integer that identifies a file, a pipe, a socket, or just about anything that can be represented by a file descriptor. In other words, sometimes it can be a file descriptor corresponding to a really huge file that I'm trying to write back to a slower device. Other times, it can be a file descriptor corresponding to a socket. Okay, I'm talking to a client, and the client is not talking very quickly. Other times, it can be a file descriptor corresponding to a teletype device, maybe a RS-232 or RS-485, serial communication device that is also extremely slow. Okay. So what it can do is it can monitor these file descriptors simultaneously, and it allows a single-threaded program to handle all the file operations efficiently without going to multi-threading or even multi-processes. In other words, you can write a program like this. If DOS had select, you would be able to deal with multiple client communication even in DOS. It's a single process, single-threaded environment, has absolutely no idea of what a multi-user system is, and you will still be able to do something like this, which I think is interesting, very, very interesting. Okay? And there are still programs written this way. They're written this way for efficiency, and mostly it is for compatibility and cross-platform advantages, because you want to write a program that you do not need special consideration depending on the target platform. Yep.
But if you're using a Linux system call, how is it cross-platform?
I believe the select call is also ported to most other modern operating systems. I don't think it's a Unix feature anymore. They may call it differently, in which case you just need a subroutine to shield it or to isolate it from the actual name of the subroutine. Yep.
Also, there are some embedded Linux operating systems that don't have multi-thread capability.
Multi-threading opens up, another can of worm too. Writing a program to deal with multi-threading opens up, a can of worm, especially programs that are using global variables. That makes it extremely hard to write, convert the program to multi-threading without, breaking something. It takes a lot of time to, get rid of all those, potential issues. Right.
It's the same call in Windows. It's the same call in Windows.
Same call in Windows? Okay. I would not be surprised because the Windows NT kernel is actually fairly modern. It is much younger compared to Unix or even Linux. Let me think. The NT kernel came about in what year? I think it is younger than the Linux kernel. The Linux kernel, for the most part, is modeled after Unix, which is a very, very old kernel in terms of design. So the NT kernel, since they redid everything from scratch, and IBM was one of the contributors to the, now called NT kernel. So I'm pretty sure it has all those modern features in that kernel. If it were just Microsoft, that may not have happened. But since IBM was actually one of the partners creating that operating system, I'm pretty sure all those advanced features were specified at the time. How many people know that Windows NT and OS2 are really twins from the same parents? You guys didn't know? You got to read up on that. It's very interesting read right there. IBM did not learn the lesson from the DOS days. They had to repeat the mistake once more.
I'm just trying to forget I ever had to use NT. I'm just trying to forget that I ever had to use NT.
NT as a kernel is not too bad. It's all the other stuff that get piled on it that made it a very bad operating system. All right. So the next topic is, what is a set of file descriptors? The select call relies on file descriptor sets. As the name implies, a file descriptor set is a set of file descriptors. How many people remember what a set is, what an element is, and so on and so forth? No? Okay, we're in trouble here. Okay.
Non-ordered collection.
It's a bitmap. Okay, you can just look at it as a bitmap. In other words, you have a long array of bits. Okay, one bit representing one file descriptor. File descriptor 0 is represented by bit 0. File descriptor 1 is represented by bit 1. File descriptor 200 is represented by bit 200. Okay, and you don't have to make this array. There's a type already predefined to give you a set of file descriptors. But you only have one bit representing one file descriptor. Is that part okay? A 1 means, this file descriptor is in the set, and a 0 means, a bit of 0 means that file descriptor is not in the set. Yep.
I want to confirm that I understand this correctly. I think that Linux has file descriptors that are specific to your process, and that those are essentially sequentially assigned starting at, I think,
Correct.
3. And so that's why this would be an efficient way to do it. Whereas if they start, if they were, say, global file descriptors, you might have one that was 63,000, and
No.
then it would be a 63
No.
kilobyte.
Every process has its own set of file descriptors. So your descriptors are always starting from 0 being standard in, 1 being standard out, 2 being standard error, and so on. So they're mostly sequential. And for simple programs like the ones that we are doing, we're always dealing with low number file descriptors. Okay. Next, the select behavior. It has parameters. It has 5 parameters, but some of these parameters we're not going to use, at least for the time being. The second parameter is a pointer to a set of file descriptors to monitor for read operations or read availability. In other words, you can configure a set of file descriptors to monitor and say, okay, I want you, select call, to monitor these particular file descriptors to see if anything is ready for me to read. At least one byte is ready. Okay? You can also set up the third parameter to monitor a set of file descriptors to see whether there's any availability to write at least 1 byte. The fourth one is looking only for exceptions, and for the most part we don't use it because there's only one exception that can be expected, and it does not relate to socket handling, so we are not going to use it. The last one, the fourth parameter is optional, so we're not going to use it. The first parameter is the largest file descriptor of all 3 sets plus 1. In other words, you have to tell select what is the largest file descriptor that we are monitoring, and then plus 1 to it. That's what the first parameter is. And you have to use it correctly because otherwise select does not work correctly. Okay. The fifth parameter, which is the last one, is also optional. It is a pointer to a time val structure. It's a timeout feature. In other words, because what select does is once you tell it what to monitor, a whole bunch of file descriptors to see whether something is available for reading, and a bunch of file descriptors to see whether there's room for writing. And once you set up all these parameters and you call select, it's going to block. In other words, it won't return until one of the monitored file descriptors has something for you to do. So if at least one of the file descriptors has something, if you are monitoring a file descriptor for read availability and it has at least 1 byte ready, or if you're monitoring for a file descriptor for writing availability and there's room for at least 1 more byte and you can write to it, select will return. But until such an event happens, it does not return. It stays blocked. Okay? What the fifth parameter allows you to do is to specify a timeout period. In other words, you can say, I can set it up in microseconds. So if you want high precision timing, you can actually specify down to microseconds. But you can, most people typically just use the number of seconds, which is one of the attributes of this structure. So you can set it up and say, if nothing at all is available in 5 seconds, return anyway. So that select will not continuously block. It will just return after 5 seconds and say, oh, nothing is happening, but I'm returning anyway, so that the server can decide what to do at that time. Okay? Timing out is actually a very useful feature, even though, okay, let me just go back to the man page here. According to the man page, any use of the timeout part is going to make the call less cross-platform compatible. But personally, I think having a timeout feature is very, very important. Otherwise, you can have programs that simply won't come back. You cannot check for anything. But when you have a timeout feature, you can say after a certain amount of time, and it is a reasonable waiting time, and you still cannot see anything that you're expecting coming back from a particular file descriptor, maybe something bad has happened. For instance, if you're using RS-485 or RS-422 communication with a controller in industrial controller on the factory floor, and you transmitted a message and you're waiting for something to come back from that particular controller, let's say normally it will come back in 2 seconds. Okay, and you set up your timeout to be 4 seconds. In 4 seconds, if nothing comes back from that particular controller, maybe something has gone bad with that controller. Maybe you should do something to alert somebody and say that, oh, that controller over there is not working anymore. Because that may be the controller that's controlling the coolant, part of a nuclear plant. Yeah, having your core melting through the floor is not a good thing. Especially when people do not even know about it when it happens. Okay, so even though it says right here, even on the man page, it says do not use that feature because it makes it less compatible with other platforms. I think a lot of programs really should use that whenever it is possible. All right, so here's the man page. Once we know the general ideas, we can go talk about the behavior, which I have already covered already. Yep.
If you didn't use that, I assume the only way to have your program continue execution while waiting, essentially while waiting, would be to use multiple threads or processes.
Right. Well, even if you use multiple threads, you still have the issue of how do we detect that something that is supposed to have happened has not happened yet. Because I'm assuming that in the case of a multi-threading program, you will allocate one thread to talk to a particular device, right? So that way you don't need to use select because your one thread is only dedicated to talk to one particular device. But you still end up with the same problem because when you're reading back from that device, the read call is blocked. It won't come back, it won't return to that thread unless there's something to read. So how do you detect that this read call has been blocked for more than 4 seconds and something bad may have gone wrong already?
Global variables?
Well, you can still do it using wait and signal, which is actually even more complicated than using the select call.
But cross-platform?
It is cross-platform to whatever is supporting pthread. And pthread is not as universal as select. For instance, Windows does not support pthread. It supports its own model of multi-threading. Okay, so the behavior of a select call is, I talked about this already. The select call will return or unblocks if and only if at least one of the following conditions is true, which means you can have multiple of these conditions being true at the same time. The first one is at least one file descriptor in the second parameter has at least 1 byte to read. Okay, so a read operation is ready for at least one of the file descriptors that you're monitoring. at least one file descriptor. In the third parameter, it has room to accept at least one more byte. Okay. The exception one we don't really talk about because it's not really useful for us. So that parameter should be a null parameter. Or the last one, which is the length of time specified by the fifth parameter, has expired. In Linux, the structure is changed to reflect how much time has not elapsed. And this one is not cross-platform. This is the part that it is referring to as non-compliant. Because other Unixes, such as BSD, like Mac OS X, they do not behave the same way. So other systems will not tell you how much time has not elapsed. In other words, Unix is using this as a countdown timer. Okay, it will continuously update this particular structure, and when it does return, this always means something. In other operating systems, that is not the case. You can always use a timestamp for that purpose too. So this is not a very essential feature. So you don't really have to rely on it. You can just use a timer and record when the select call was made. Just right before the select call, you take a snapshot of the timer, and then right after it returns, you take another snapshot. The difference between those two numbers will tell you how much time has elapsed, when you made the select call. The select subroutine also has a return value. The return value is the number of monitored file descriptors that has pending bytes to read, room for at least one byte to write for, or an exception. It is a sum of the number of the file descriptors. It does not reflect the highest number of the file descriptors. It tells you the number of file descriptors that is ready and have something that you can do. A single file descriptor can be counted up to three times if it is in all three sets. In this case, we're only dealing with the first two because the last one, as I said, are typically not used in a regular program. One can also say that the return value is the total number of elements in all return sets set to a 1, basically. And this return value would be 0, which makes sense if the select call returns because of timing out. Because if it does time out, it means nothing is ready. The only reason I'm returning is because that much time has elapsed. Are there any questions about the behavior part of the select call?
What is it? So, how much time has not elapsed? So, can you explain that a little more?
Which part?
Just
the highlighted portion here?
Yeah.
So let's say you set it up to 5 seconds, and within the first 2 seconds, at the second that you're waiting, one of the monitored file descriptors has something available. So either a byte to read or a byte to write to. So select will return. So in that case, what happens in Linux is the number of seconds in the structure will be changed from 5 to 3 because 3 more seconds have not elapsed according to the timer. Okay. Yep.
So how do you know from select which file descriptor needs to be serviced? It's by looking.
Good question. I like those. Come on. Okay. So that question can be answered by reading the man page. Look at these 4 quote-unquote subroutines here. They are all designed to deal with each one is designed to deal with a set of file descriptors. They all have slightly different, they all have their own purposes. We'll start with fd0, okay? Okay, we'll start with fd_set. fd_set is a struct or a type that is defined in either select.h or types.h. I cannot remember which one, but it's a type. Okay, you can see in the prototype here, it is just used as a user-defined type or type def, and it is a set. In this case, is a pointer to the type fd_set. What fd0 does is it will turn the entire set to zeros. It resets everything. Okay, so that's really useful for initialization purposes. And then you have the next one, which is fd underscore set, which means in this case, the second parameter set will determine which set are we talking about, because you need one set for read operations and one set for write operations. So this one allows you to specify, okay, which set exactly are we talking about? And then the first parameter is saying, okay, which file descriptor are we supposed to turn to a 1 in the set? Okay. So if you say 5 here, and then that means bit 5 of this set will turn into a 1 without affecting any other bits of the set. Are we doing okay? So are we doing okay with fd set? Fd clear does exactly the opposite. Okay, whatever file descriptor number you specify will be cleared in this particular set. It just turns whatever is a 1 back into a 0. It does not change something that is already a 0. It just turns that particular bit to a 0. Now this one is useful because at some point you have to check exactly which file, as you mentioned, exactly which file has a byte to read from. So what you need to do is to scan through the set until you find one that has that particular bit position being 1, and this is the function to use to check whether it is set or cleared. Are we doing okay so far with this? Yep.
I have a question about including the files for this. I think we need to include cis types.h elsewhere, or at least we may. And if the declaration of those is in there, then wouldn't that conflict with using cis/select.h? Wouldn't we have to use the earlier standard?
Say again?
You mentioned that that you thought these might be defined or declared in cis/types.h, but it says at the top of the synopsis you can use 2 different ones.
Right.
I thought we might already be using.
They do not. They use a trick so that they do not conflict.
Okay. In that case, do you know which one would take precedence?
I think we should use the first one because, well, Unix is not entirely POSIX compliant, so I'm not even sure whether that will work or not. We can test it, but it doesn't really hurt to include all 4 #includes 2 because it doesn't define the same type def twice. What it does, okay, this is also a trick that is fairly common when you write programs. So let me go back to the note here. Okay, we are not going to write any header files, anytime soon. But when you write a header file, let's say p-error test has its own header file because it's getting complicated, and I have to break out the program into multiple files. So the first thing I would do is to say if ndef underscore, in this case it's p-error test underscore h. So this is a test to see how much you know about macro definitions. And then I will put all my actual header definitions. Go here. Okay. So what I'm doing here is to see whether that particular macro is already defined. In the case of I'm including this file multiple times, the first time the preprocessor will say, oh, okay, underscore p-error test underscore h as a macro has not been defined. So if it is not defined, it's going to go through the rest of this program or the rest of this file until it encounters #endif. Okay. But the second time, if I #include this the second time, then p_p-error test underscore h would have been defined already. So that means this condition is false, and it will skip the entire content of the header file. So they use a similar trick to deal with situations like this. Basically, they can check whether a particular file has already been #included, and if it does, then it is not going to do anymore. It is also possible that in this particular header file, it just #includes the other one. Which also works because each header file has its own check to see whether it has been #included already. Any other questions about the select call? Yep.
So does the select call use the FD underscore functions?
You have to use those in order to handle
Okay.
the FD sets, because that's the only way to to process
Check, right.
these particular types.
Got it.
One is useful for initialization.
Right.
One is useful for checking which one is a 1, which one is a 0. One is useful for clearing, and
Okay.
one is useful for setting.
Right. Cool.
Yep. Do we have any questions up to this point about the calls? This is the select call itself. This is already discussed. The first one indicates the n FDs, number of file descriptors, and this is the highest number file descriptor plus 1. You have to remember that plus 1, otherwise it won't work. Okay. This is a pointer to a set of file descriptors for read monitoring. This one for write monitoring. This one, for the most part, we don't really use. You can just apply a null here. A null pointer means we don't have anything to monitor. And then the last one is also optional. If you supply a null here, it simply means that we are not timing out for any period of time. The whole thing it just won't unblock unless something is ready. Are we doing okay so far with the select call? Now, how do we write a program to use the select call? It's pretty easy. We can just use read and write operation to use the select call. So, we still have 5 more minutes, so we'll go ahead and actually write this program. What I'll do here is I will do the pound include. We'll go ahead and try pound include. What is it? Select cis/select h. Okay. So what I'll do is I'm going to use a underscore fd underscore set. Yep. So I'm going to define a global one for read and just one for read is fine. Okay, so we'll say read set, and then right after that I will have to initialize it first. So fd0 is going to initialize the whole thing, but you have to pass a pointer to an fd set to it. So not the fd set itself, but a pointer to it. So I'll reset it, and then we'll go ahead and set one of them. In this case, I'll set file descriptor 0 because I'm trying to see whether standard in has anything to read. And supply read set here. Okay. So when I make the call, I can make a call inside. Okay, let's do it outside. We'll do the while loop here. I'll specify the exit condition later. Okay, so inside here we'll have int select return value. Select return value equals select. And remember what the first. Okay, how should I set the first parameter in this case? It's the highest number file descriptor plus 1. Just be 1, because the highest file descriptor is 0 itself. 0 plus 1 is 1. The second one, I have to supply the address of the file descriptor set. And then I don't have anything to monitor for write operations. Don't have anything to monitor for exceptions. Don't have a timeout period. So all of those will be null characters. I mean, null pointers. And then the first thing we'll do is to print out the return value. Select returns certain value. And in that case, we'll say select return value. And we'll also see whether the read operation is blocking or not. The read operation is always blocking, so I guess we really don't need to do that. So we'll say read from file descriptor 0. Well, we'll also do this part. How about this? We'll say fd is set of fd0 returns a number. We'll just go ahead and reflect that number, and it will just be fd is set. We're trying to set whether we're trying to see whether file descriptor 0 has a bit of 1 or 0, and it is out of read set here. And then we perform the read operation. I have to give it a buffer to read to. And let's also deal with the exit condition of this. And read value. So this is basically a program that doesn't even echo anything back out. All it does is to monitor the file descriptors.
Does sysselect.h include stdio.h?
Sorry?
Does your header file there include your input-output stuff since you're using printf?
Oh, very good. Forgot about that. All right, and we'll just go ahead and add one more printf here. Finished reading, and the purpose of this line will be clear a little bit later. Okay.
Do you want that in the do while loop or outside of it? The finished printing or finished?
No, I want to do it inside the loop.
Inside?
I want to do it right because I want to indicate whether the read call itself is blocking or not.
Okay.
GCC-O C. Okay. So every time I press, I enter like one character and then the return key, it will do 2 of those, which is normal, because okay, in this case A is 1 character and then the line feed is another character, so that makes sense. If I give it more characters, it will do the same thing, multiple times. But you can also see that it only blocks after it says finished reading. It never blocks between fd is set of fd0 returns 1 and finished reading. In other words, I have moved the blocking point from the read operation to where? To the select call itself. So now I can block on multiple file read operations. In other words, I can have, after the select call, I can use fd is set to determine which file descriptor I should be reading from and process as a result. Okay? So what I want to do, okay, I know I'm running a little bit over, okay, but what you can do is to basically say, okay, let's get rid of the select call and see what happens. Okay, get rid of this part. This is also another little neat trick here to get rid of one particular block of code. So what I have done is I have completely taken out the select call and everything that is associated with the select call. So I will do something like this, and this is going to say before reading, and this time the block is going to be before reading. It will block if I enter something, then it will unblock and go through the loop a few times, and it will block again, printing before reading. Okay. So we'll go and GCC again, run the program again. So it is blocking. It prints before reading, and then it blocks. I press a key, it reads 2 characters, and it always blocks at that time again. Okay. So this program really just illustrates how the select call is being useful. So for those of you who want to make this even more fancy, you can say pound if use select. Okay. So if you have a macro used like this, you can actually control the compilation by using -D use select here. In other words, -D use select as a command line to GCC is the same as doing #define use select inside the program. So you can actually integrate this into a makefile to automatically switch a program from one version to another version. The other way to do it is to use a switch on the command line, just like what we did at the beginning of the class. Then you can say, select test -- use select or something along that line. So the choice is up to you, but the program does illustrate the use of the select call and the impact that it has on the program. Okay, so we're running out of time today. I'm going to stop here.